Good afternoon, students. So myself is Subham Banerjee. So today I am going to discuss about this continuity and differentiability, that is chapter number 5, class 12 CBSE. So before that, I will discuss basic concept for your limits that already you studied in your class 11. Okay. So first of all, what do you mean by limit? Okay, actually limit is one kind of tool which is actually mathematical tool which we can apply on the curve. Okay, apply on the curve. Basically this is your tool. This is your tool which we can apply on the curve. Why we can apply? Because we have to find the behavior or character of the, so we have to find the behavior or character of the function or curve. Okay, so that's why we have to use the limit. Actually limit is a mathematical tool which we can apply on the curve. Why we can apply? Because we have to find the behavior or character of the function. Now what do you mean by behavior or character? So basically this character, so there are two type of behavior or character on the function. So now namely one is your continuity. One is your continuity, another is your differentiability. Okay, so there are two behavior or character, so that is actually function gives or provides. So we have to find our behavior or character. For that case we have to need the limit tool. Okay, so there are two type of behavior or character. One is your continuity and another is your differentiability. These two behavior which comes from your function. Okay, comes from your function. Okay, so now this continuity and differentiability we now studied in your class 12 chapter number 5. So let's start. That is, what do you mean by continuity? Okay, so now I am going to discuss about your definition of continuity. So let's start. Okay, so for continuity, now comes to your continuity. Okay, continuity. So actually continuity, that is obviously this is apply or related to your function. So if we draw a curve without lifting the plane, if we draw the curve without lifting the plane, so obviously this is continuous. We can draw continuous way. So this type of function or curve we call continuous function. This is a non-mathematical definition, but for your understand you can remember, that is, if we draw a curve, without lifting the plane, without lifting the plane, so that curve is your continuous. Okay, that curve is your continuous. If I draw this type and here, so this type of curve is not continuous because we can't draw this curve without lifting plane. So here you see that this is your discontinuous. Let's see here, you just draw this type and start again. So for that case we need lift the plane. So that's why this type of function we call non-continuous function. So for continuous function, so if you draw the curve without lifting the plane, so that curve we call continuous. Okay, so now let's take one example. Okay, let's take one example, and after that I will define the definition, mathematical definition for continuous function. Okay, mathematical definition for continuous function. So let us take, for example, let us take fx equal to, let us take 1 x greater equal to 0 and equal to, let's take -1 when x negative. Okay, so let's see. So now I can draw this curve. So let's take x-axis and y-axis, x o x dash and y o y dash. Okay, now function is defined, that is y equal to fx. This is your defined function, be defined here. So first you see that when x greater equal to 0, the value of the function is 1. So x greater equal to 0 means right hand side of x-axis. So when right hand side of x-axis, the value of the function is 1. So let's take, this is your 1 for y1, this is your -1. Okay, so when x is positive, the value of the function is goes to for 1. So that means this type of line we can draw. Okay, and when x is negative, that is -1. Before that, look at this, x greater equal to 0, that means 0 is included. So when x equal to 0, the value of the function is also 1. So that's why you have to dark circle here. Okay, now comes to your negative case. When x negative, the value of the function y equal to fx equal to -1. So that means you can draw like this. Okay, you can draw like this. So here, that is only x less than 0, not include 0. So that's why not include 0 means this -1 is not included here. So that's why you have to mark, that is blank circle. Okay, because this is exclude, because this is your exclude. Fine. Okay, next. So now clearly you see that we can't draw this type of curve without lifting the pen. You know, if you draw this type of curve means we have to need lifting the pen. Okay, so that's why this is your not continuous function. Not continuous function, because we can't draw this type of curve without lifting the pen. So that's why this is your not continuous function. So this is your non-mathematical definition, but now comes to your mathematical definition. Now we can use the limit term. So let's see. So can you tell please? Here, look at this, your definition of function. Here, clearly you see that this 0 is a breakpoint. This 0 is a breakpoint. X greater equal to 0 means value of the function is 1. When x less than 0, that means value of the function is -1. That means 0 is a breakpoint. So basically, we have to check the continuity at that breakpoint, which is your x equal to 0. X equal to 0, that is your breakpoint. So now we have to discuss about the point x equal to 0. Is this function is continuous at x equal to 0 or not? So let's start. Let's see. Now, so when we comes from left side to close to x equal to 0, the value of the function is -1. When it comes from left side to close to 0, the value in that case, that is your -1. Okay, that is your case, fx equal to -1. And similarly, if we comes from right side to x equal to 0, in that situation, value of the function fx equal to 1. Okay, when we comes from right hand side to close to 0, the value of the function is 1. When comes from your left side to your x equal to 0, the value of the function is minus 1. So that is actually left hand limit. That is actually left hand limit. And how we can represent your left hand limit? Class 11. Limit x tends to 0 negative fx, because we have to check at x equal to 0. X negative means that is comes from left side to close to 0. So that's why 0 minus fx. So left hand limit x tends to 0 fx equal to minus 1. Okay. Similarly, from right hand side to close to x equal to 0, so that is mainly your right hand limit. That is your right hand limit, and we can represent right hand limit, that is limit x tends to 0 positive fx. In that situation, value of the function is 1.